Alright, welcome everybody, let's do this. Today we're going to go over L'Hopital's rule. Hopefully this video is going to be like really short, really fast. It's a little tricky at first, but with some practice problems we'll get better. L'Hopital's rule. What I want you to do is pause the video and copy this down, and also we're going to copy something below. But here, assume f of x and g of x are differentiable. This means that we could take the derivative at some x equals a and assume that g prime of x is not equal to 0. What this is saying is that, let's say if we want to find the limit as x approaches a, if the functions are both differentiable, we're allowed to just take the limit with respect to the derivative. So what on earth does that mean? You're like, Mr. I have no idea what you're talking about, but that's okay. I mean, for now, of course I'll explain it later in the video, but here, copy this down as well, and we'll go over it together, right? So let's say you copied it down. It says, when evaluating limits by direct substitution, we'll talk about that soon, there are 7 expressions known as indeterminate forms, such as 0 over 0, infinity over infinity, 0 times infinity, 1 to the infinity, 0 to the infinity, infinity minus infinity, and infinity to the 0. Okay, so if we have something in this form, we say it's the indeterminate form. All right. So L'Hopital's rule states that when f of x and g of x has an indeterminate form of 0 over 0 or infinity over infinity at x equals c, we can replace the f of x and g of x with the derivative of the top and the bottom. Okay. So let's do an example to see what on earth I'm talking about over here. So let's take a look at this. Here, just from what we learned about today, if I were to tell you, okay, what's the limit as x approaches 2 for this function over here, okay? And some of you are like, all right, easy money. So what I want you to do is try and do this one, factoring, right? So let's say if you were to do it, notice that it's the limit as x approaches 2. So let's factor the top. What do we get? We have, I'm sorry, what am I doing here? How does the top factor? It is x, what is it? X plus 3, x minus 2, and then what's on the bottom? It should be x plus 2, x minus 2. Okay? Because here you ask yourself, can you plug in 2? You can't, so you have to, you gotta factor it, right? So here, notice the x minus 2's cancel out, so the limit as x approaches 2 of x plus 3 over x plus 2, well, that's just equal to, now you're allowed to substitute 2, so that's 2 plus 3 over 2 plus 2, and that's equal to 5 over 4. Okay? But, yeah. Now, how can we do the same question using L'Hopital's rule? L'Hopital's rule states that if you can take the derivative at some x equals a, so can you take the derivative of the top and does the derivative exist for the numerator and does the derivative exist for the denominator at x equals 2? Yes, because they're both polynomial functions. So here, what you're allowed to do is, you're allowed to say, instead of taking the limit with respect to this function, what's the derivative of the top? Notice that you're allowed to do this. The limit as x approaches 2 of x squared plus x minus 6 over x squared minus 4. Notice that you're allowed to say that this is equal to the limit of, let's see, 2x plus 1, which is the derivative of the numerator, right? What's the derivative of x of this? It's 2x plus 1. As x approaches 2. And what is the derivative of the bottom? It's just 2x. And now here, what happens when you plug in x equals 2? Notice that you get 2x plus 1 over 2x as a limit as x approaches 2. Oh my god, what is it? It's 2 times 2 plus 1 over 2 times 2. It's equal to 5 over 4. Wow! Oh my god. You can actually do this. It actually works. L'Hopital's rule is pretty nice because instead of like having to factor this, just take the derivative of the top and bottom and plug in 2. It's very nice. All right, sorry for the mess over here. But I got really excited, and you should get excited too, right? So let's take a look at something like this. Here, and we're going to talk about this example of this indeterminate form right now. But for this example, let's say we have the limit as x approaches infinity for e to the x over x squared. Now here, let's say if you just directly substitute. So let's write it here. If I say the limit as x approaches infinity of e to the x over x squared, you're saying that this is e to the infinity over infinity squared. Like if you were to substitute x for infinity. And notice, what is e to the infinity? That's infinity. What is infinity squared? That's infinity too. So this is weird. Here, notice that we have this indeterminate form that we talked about before. Let me zoom out a little bit. This indeterminate form that L'Hopital's rule states that when f of x and g of x have the form of 0 over 0 or infinity over infinity, what you're allowed to do is you're allowed to take the derivative of the top and the bottom. So here, let's try this again. Let's take the derivative of the top and the bottom. So limit, let me zoom in. Okay, that's better. Limit of e to the x over x squared as x approaches infinity is the same as, well, let's take the derivative of the top. What is the derivative of e to the x? Pause the video and try and remember, look in your notes. What is the derivative of e to the x? Derivative of e to the x is e to the x. Okay, so what we need to do is continue this. So we say the limit as x approaches infinity over, now what's the derivative of x squared? Notice that it's 2x. Okay, but you see the problem is if I plug in infinity, what happens if we plug in infinity? We're still going to get some infinity over infinity. So it's still a little weird. So what you're allowed to do is you're allowed to, let me write this down. You're allowed to repeat. So you're allowed to take the derivative again. So let's take the derivative of the top. What's the derivative of the top? It's limit as x approaches infinity of e to the x over 2. So now what do we get? We have some infinity over 2, but then that's just the same as infinity. So we know that for this limit, the limit as x approaches infinity of e to the x over x squared, that is equal to infinity. Okay. Okie dokie. Let's try the next one. Here, this one over here. Now this one will be very nice for us. So here, it says the limit, and I kind of dragged this line, this is a little sloppy, but here the limit as x approaches 0 of sine of x over x. Now here, are you allowed to plug in 0? No, because what is sine of 0 over 0? Well, what's the sine of 0? Oh, sorry. What is the sine of 0? That is 0. And so you have 0 over 0. So notice we have this indeterminate form of 0 over 0. So now what we're allowed to do is we're allowed to use L'Hopital's rule to take the derivative of the top and the bottom. So this is equal to the limit as x approaches 0. Now what is the, what is the derivative of sine of x? Right? Pause the video. Don't wait for me to do it. But it's cosine of x, right? And what's the derivative of x? 1. So now you have the limit as x approaches 0 of cosine of x over 1. Can you now plug in 0? Well, let's see. What is cosine of 0? Cosine of 0 is 1. So now you just have 1 over 1, which is equal to 1. So then you know that the limit as x approaches 0 of sine of x over x, this is equal to 1. Okay? L'Hopital's rule is very, very nice. It's just really helpful. Let's look at this one. What I want you to do is try and use L'Hopital's rule over here. Okay? Take your time. Right. So notice that when you plug in infinity, you get some infinity over infinity. Okay, so we could use L'Hopital's rule. So what happens now, this is equal to what? Limit as x approaches infinity of 2 over, oh sorry, let me write it here, 2 over 6x, right? Now, can you notice that, can you plug in infinity now? Sure, but then what do you get? You get 2 over 6 times infinity, that's just 2 over infinity. And this is just equal to, what is 2 divided by infinity? This is small number divided by very big number. Very big number. So then this should be equal to, this is just equal to 0. Because let's say if I have like 1 over infinity, this is very, very, very close to 0. Okay, because this number is very, very large and this number is very, very small. So we know that this is equal to 0. Okay. Let's try this one. Here, we did this, and this is the last example. We did this example in class. Try and look at your notes, but how did we actually do this question today? Try and don't think about L'Hopital's rule right now, but we did this question in class. What I want you to do is look at your notes. So how did we actually do it? We did square root of x plus 1 over square root of x plus 1, like this. And then we foiled the top over here. Hold on